That's all you get. Believe it or not, Napoleon Bonaparte and his French army took over half of Europe. That was the style of music they had back then. Lots of brass, lots of drums, none of this electronic stuff, okay? All right, so you're here because you want to know about molarity worksheets. You want to know how to solve molarity problems. Well, I got you covered. Because my name is Trev Lucas Spa Woo, and Grandmaster C personally asked me to help you guys out on this. Okay? So, let's go with it. Let's do a quick recap. You talked about solutions. In a solution, you got two main parts. The solute that gets dissolved and the solvent that does the actual dissolving. So, we have to understand about concentration, okay, of a solution. And using words like concentrated or dilute, that's not going to work. We need something more precise. And there is percent by volume, which that's great. The general public works with that, like rubbing alcohol 70%, okay? Vinegar 5% acidity, okay? Hydrogen peroxide 3%. Weak sauce! Yeah, I know. But remember, we can only handle the weak sauce. So don't sit there and put down the weak sauce, okay? That's not good. So let's go with it. We're talking about molar concentration. You'd say molar, isn't that thing like, that's one kind of molar, that's your molar tooth. That's not it here in chemistry. In chemistry, the molar is the concentration unit, okay? And the basic unit behind that, we use a capital M for molar, and that is equal to moles over liters. That's it. Okay? That's the basic formula. Okay? So I'm going to show you guys a few problems and how we can put all this together. So it says, how would you prepare 1 liter of a 0.35 molar of HCl solution? Okay, so when they use the words, how would you prepare? That means, how many moles of HCl am I going to need for this? Okay, I know I have 1 liter and it has to be this concentration. What's my mole? What is being asked and what is given? Okay, so I have a given. I also have a given. This is what's asked. But wait, what do you mean by what is asked? They're asking for how many moles is it going to take? Okay, so remember, you're tearing apart a problem for this. That's the life skill you want to take with you. Okay, what's the information you're given and what are you asked to do? Once you can do that, that's going to help. So let's go and look at this. I can tell you right now, I got this formula here. I can go ahead and plug in the numbers into the formula and use the algebra to take care of that. Okay, let's see how that works. I have 0.35 molar. Now notice this is this is a capital M. That's for molar. The MOL, not LOL, MOL is the number of moles. This is not moles, this is molarity or molar. Okay? So that's what we have, and that's going to equal how many moles, and they gave us the information here of 1 liter. I can abbreviate that with the letter L. Wow. Wait. Trevluca, seriously? That's it? Yeah, that's it to set up this problem. Okay? All right. How do I go solve it? Not a problem. Remember, what you do to one side, you do to the other. So I can go ahead and multiply both sides times 1 liter. Why would you want to do that? Watch this. I have 1 liter times 0.35 molar is equal to the number of moles that I have. Because that's what we're asking for, right? We're asking for the number of moles. So in looking at that, it's like, okay, but I've got this liter and I have this molar here. How does that... Okay, watch, Padawan. If you know what molar is made up of 2 pieces, a top part and a bottom part. So let me rewrite it. I have 1 liter multiplied by 0.35 moles per liter is equal to moles. See, that M, that big M, is equal to moles over liter. It doesn't matter if it's mole or moles, or liter or liters. It doesn't matter at all. It's the same unit. Okay? So now that we have that, guess what? Liters cancels out beautifully like this, and we're left with moles. So our answer, guys, is going to be 0.35 moles of HCl. So that's our answer. So we need 0.35 moles of HCl over 1 liter, and that's going to give us the concentration of 0.35 molar concentration. That's it. That's all that there is to it. Okay? Let's go ahead and try another one. Okay, let me erase this. Now I do have another molarity video. This is the 2020 version, okay? But you can check, I believe, you should be able to check on my website, okay, for that. So I'm gonna go ahead and let's try another one, okay? And what we're gonna do, we're gonna change our liters, okay? So instead of a 1 liter, I'm gonna go and have a 2 liter. I'm gonna have 2 liters of solution, okay? Now in real world, if you're in a lab and you need to go and water down something, lower the molar concentration of something, you add distilled water to it. That's what you would typically do. I have to do it for you guys for some of your labs. I have to water down some of that stuff because if you get it on your hands, it's going to be okay. So I have to water that down, and I can figure out the concentration. It's not a big deal, and you're still getting the results in your lab. So let's go ahead. I'm going to cross this out, and I'm going to say 2 liters of a 0.35 molar of HCl solution. Okay, so let me see. If this is my formula, molar is equal to moles over liters. My molar hasn't changed, right? I got 0.35 molar. I'm going to go ahead and write out the word so you can see where this is coming from. Is equal to, we don't know how many moles, over 2 liters. So I'm writing out the units so you can see. Now, does it make a difference if it's liter or liters, or mole or moles? Not one bit. Not one bit. Okay? So with that, how do I go and solve the problem? Well, I'm going to get rid of this 2 liters. And I can go ahead and multiply this side by 2 liters. And I can multiply this side by 2 liters. Right? So what is that going to look like? Well, I'm going to have a 0.35 moles per liter multiplied by 2 liters is equal to however many moles times 2 liters over 2 liters. In other words, I'm showing you where the multiplication is coming from. Okay? And the basic thing in math, always remember, anything over itself is 1. This goes away, this goes away. So now I'm left with X number of moles. I have 0.35 moles per liter times 2 liters. Oh wait, if I multiply this out, what's going to happen? Well, let's check it out. If I multiply this out, then I should be getting 0.35 times 2 is 0.7, so it'll be 0.7 moles times liters, right? Because we have the liters here, divided by liter, right? And that's equal to however many moles we need. And if you notice, again, does it make a difference if it's plural or singular? No, it does not. These will divide each other out nicely. So my answer, ladies and gentlemen, here it is. X is equal to 0.7 moles. So that's what you would need. You would need 0.7 moles of HCl. Okay? Okay, so the next question is, well, a mole is a number, and we need to weigh that in grams. But I have numbers. How do I change that to grams? I gotta look at the timing here. I have to look at the grams. How do I do it? Okay. This is where we are going to go from moles to grams. Remember, you're going to multiply, aren't you? And what do we need to do? Well, we need to find out. We have our H, we have our Cl, right? We can look on our periodic charts. 1.01 and 35.45. Again, those numbers were not coming out of thin air, okay? It didn't come out of some celebrity's ego. Those are real numbers from our periodic chart. And we have 36.46 grams per mole, okay, of HCl. So now I got 0.7 moles, right, multiplied by 36.46 grams per mole. And look at that! The moles cancel each other out again. So we're left with grams. Of course, the question is, Canu, I got to get to the number. Oh, that's not a problem, man, because you know when your units are canceling out, then you can calculate with confidence. The kind of confidence that only Calculon himself can put out. If you know that reference, have fun with it. If not, don't worry about it. Okay, let me get out my calculator, hit the clear, and I got 0.7 times 36.46 equals. So I walk away with 25.52 grams of HCl. That's what I would need to add to the 2 liters of water to make that solution of 0.35 molar. That's it. Okay? All right. Let's try another one, shall we? Let's try another one. Now remember with this, you can rewind it, go backwards, forwards, okay? I'm gonna go ahead and I'm gonna work on this next problem. That's gonna be my last one, okay? So in this problem, this is out of, those two problems that I worked on came out of your worksheet, okay? I'm gonna modify the worksheet a little bit, that it'll be a little bit more clear what I'm looking for. So here, what is the molarity of a solution composed of 5.8 grams of potassium iodide, Ki, dissolved in enough water to make 0.125 liters of solution? All right. Some things here. What am I given? I am given this. I got 5.8 grams of potassium iodide. Okay. And I'm also given 0.125 liters. Okay. Now, what am I asked? I am asked for the molarity. That is what you guys have to be able to do. What is given and what is asked. Now, so now you know you have molarity. They're asking you that. They give you the grams and they give you the liters. And you got your formula that molarity is equal to moles over liters. Moles over liters. And of course the thing is, but wait, we were given grams of potassium iodide and they want moles and we can't put 5.8 grams into the formula. What am I gonna do? Oh, grow up. Come on. You can change this. You have the ability to change this. Can we not change this into moles of Ki? Of course we can. Wait, if we go from grams to moles, well, what do we need to do? You divide. You divide. Okay, so what am I putting on the top? What am I putting on the bottom? Well, I'm going to put my 5.8 grams on the top, because that's what I'm asked, that's what I'm given. Now I need to know, let's see, Ki. So I need to know how much my potassium is. That's 39.10, and then I have to look for the iodine. Woo, that's a big boy! 126.90, like that. Okay, so I got 0, 10, carry the 1, 1 and 9 is 10, plus 6 is 16, carry the 1, 1 and 3 is 4, 4 and 2 is 6, and then we have a 1. So we have an even 166 grams per mole. That's what we have, ladies and gentlemen. Okay? So with that, guys, we can go ahead and put in our calculator 5.8 divided by 166. Okay, and I got rounding, I'm going to round to 2 decimal places. I have 0.349. Okay, guess what? On 0.0. Well, the day is long. What can I say? It's going to be 0.0349. I'm going to round that to 0.035 moles. Okay? I'm going to have 0.035 moles of potassium iodide. Okay? Now with that, ladies and gentlemen, now that I've got the moles, I can now plug that in to the formula. Molarity is equal to